It doesn't matter how smart the agent is. If it doesn't have the right context and the right data, it will not make the right decisions. Hello, and welcome to Generation AI, where we demystify artificial intelligence in the world of higher education and beyond. I'm your host, Ardis Kadiu, and with me today, I have a special co-host, Petar. Hey, Petar, how's it going?
Hey, Ardis. Glad to be back. I think it's my third time.
I know we usually don't have any guests, so you're the only guest that we've had now for a third time. You know, a lot of things have happened with you over the last year. You're dad now too.
Yes, I am. That's the highest title I've got so far. And now I'm trying now to take the JC's role here on this podcast. I've been eyeing positions for a while.
Depending on how you do today, we might have a contender here for co-host. So one thing that's really interesting is JC comes with an accent, so it sounds like we need you come with an accent too. So we need the accent as well.
Yeah.
Okay.
No worries.
That's good. That's good. Well, folks, today I have Petar on because we're going to discuss kind of this evolution of what we have traditionally called prompt engineering in AI and this large language models. For those of you who have kind of followed, like we've talked a lot about prompt engineering in the past. I even had a prompt engineering course because that was the way that you were able to unlock a lot of really, really good output from these large language models as GPT 4 and GPT 4.1 and so on and so forth came around. And this has been an area where there's been a lot of, prompt libraries and techniques and so on and so forth. However, over the last 2 years, what we've seen is a transformation of these models becoming more reasoning models and not necessarily having a locked in capability of the knowledge. So if you remember GPT-4, they had knowledge locked in a certain period of time, and then now you had to provide a really impressive prompt in order for you to get some really good information out of it. What's happened since then is that we have progressed into reasoning models, and these models are now using tools to go get information in real time and feed it in depending on the type of questions that you ask or depending on the types of jobs that you have. And that's actually something that we talked about agents as well, and agents have that same exact kind of capability and that same exact loop where they reason about the question that you're having or the task that you're giving. It uses tools to go out and gets more information or the context, and based on that context, it's actually completes that task. So what we're going to talk about today is this new kind of paradigm or new technique and new title or whatever you want to call it, but it's called context engineering. So how do you build the context, and how important is the context in the AI for getting really amazing results and for making this AI is really, really smart? This actually goes into it's very important for a lot of different things, and we're going to explore a lot of that today. Petar, how does that sound?
Sounds great, Ardis. Sounds great.
Okay.
We've been doing a lot of context engineering in Element, so this is right up our alley.
Well, one of the things that you told me as we were preparing for this episode, you were like, damn, we've been doing all of these different techniques and all of these things over the last couple of years, but there's just so many different definitions and words now that people have assigned to these different techniques. So
yeah, this it's funny because kind of like this whole new kind of like AI era now, even though like AI existed before, but kind of like when large language models became kind of like de facto standard now. We kind of jumped on the train early, like 2-3 years ago, when we started to use it and try to incorporate it into the product. And we were not experts at that time, right? And even now, it's a little bit weird to say you're an expert with something that's so brand new.
Yeah, nobody's an expert, right?
But,
it's like, yeah.
Is it so? We kind of like learned as it progressed and as we were using it, and kind of like a lot of it is common sense thinking, like with engineering background and like common sense thinking of building systems and kind of like what's right, what's wrong, and kind of like using the right tools. But what's interesting to me and funny, what I had a revelation, especially now, is as we prepared a little bit for this topic, is a lot of people now are starting to label things, like to give, specific words like the context engineering. Then you have certain problems with context engineering. It can be like, for example, context poisoning, context confusion. And I remember from my school days, like when you go and you don't know anything about a certain topic, and like, you get a curriculum and you get like you read from a book, and you need to learn these labels like on top, and like sometimes recite them, depending on who's your professor. So, and it's funny because I now see that becoming the norm, right? And I can expect that like, our kids will actually learn about this in school with this way. Like you actually use these words and these phrases that actually that captured the kind of popularity.
Yeah, if you label something, it exists, right? It's like if you name it, it actually comes to life. So we're kind of in that same thing. So as context engineering discipline emerges, it really focuses on kind of building this more dynamic systems, and you need a lot more labeling because this is evolving, right? It's evolving discipline that's happening.
You're basically defining patterns. Like
Exactly.
all kind of like solving the same problems. Now we just want to like settle on the same kind of like same nomenclature so that we can better use the knowledge that everybody else kind of like built up. But yeah, it's evolution. It's an evolution of the prompt engineering. It's still prompt engineering because you are essentially building a prompt. Like every LLM call is a prompt. So it's just structuring the prompt to have the right information for the LLM for that next step. That's kind of like what context engineering is. Just giving it enough information they can do the task at hand for this current step.
So let's focus on that then. Let's talk about, like, a lot of folks know what prompt engineering is, or prompt design, or whatever you want to call it. And this large language model is one of the reasons why prompting became really powerful, is because these models are designed to, you can steer them in different directions, and there is certain patterns that you can provide in order to steer them in separate directions. And because they have built with reinforcement learning, meaning that they have patterns built into it, so they respond really well to certain ways of introducing content to it or asking questions a certain way. We came up with prompt engineering. So there was this, you try certain things, and we get different results depending on what we tried to ask it, how we asked it. If there is an action verb plus you provide the additional information of what you're trying to do. In some cases, you actually give it a persona, and so on and so forth. So those patterns were really, really good, and we had these really large prompt libraries that we came up with. So you paste that whole big prompt, and then now it's a one shot, and now you get the information out of it. So what's the difference between prompt engineering, and context engineering?
So you're saying a lot of things in the past, like we did with it, but we're still doing that. So it depends on the model. Models are becoming smarter, so some of the techniques that we used before might not be needed today. But if you're building a product and you're like trying to find like the best model for the job at hand, and also to be cost effective and kind of like economics to make sense, like you also need to employ these techniques sometimes to use maybe a model that's not maybe top of the line to get good results. So let's assume that all the things you learn about prompt engineering is still valid and you are still using it. So why are we now talking about context engineering?
So it's an evolution. You're saying it's an evolution.
Yeah, it's evolution, and also like we actually were doing context engineering before, we just didn't label it. So it's maybe let's say that we are kind of like making it a bigger deal now. We want to focus on it because we want to create it to be a field. We want to create it to be a field, more patterns, to have strategies, and to have engineers think about it in a structured way. So that's why it will become its thing. And you can think of context engineering. I'll give a simple example. Imagine that you want to build just an auto reply chatbot, right? Just an auto reply. Well, what do you need to do, right? If you think just manually, like not even doing any coding, that you would copy some email you got, you will paste it into a large language model and say, "Can you answer this?" Right? Well, that's already context engineering, right? Because you are putting the context of what was their last kind of like message that you got, and you want the response. That's already a form of context engineering, right? You're just manually doing it, right?
So what you're saying is that the difference between a prompt that you had and you always pasted in, and context engineering is the dynamic context that you swap different things in the prompt in order to provide the right context
at the right time, right? For that task, right? If the task is replying, then what you need to reply as a human, right? You will need to look at what previous message. But then it gets more nuanced, right? Because sometimes it's not just the current email that you got, right? Sometimes you need to look at the full thread, right? Sometimes it goes a little bit bigger. What if I had multiple threads with that same person, and like I need to look up all of them? this is where things get interesting. Like how do you build it in a way to take all these things into consideration, right?
So what you're saying is that so then the evolution is, look, we had this one shot problems that we were trying to do before. Like we were producing marketing content, we were producing a lot of things, and prompting was great. But context engineering is the problems have evolved, and now as we have this more specific agents that are using tools, they need to bring in information from different systems or different storage or different memory places in order to answer that particular question or in order to complete that task. So the fact of going and picking that information from different places, retrieving that information is in essence context engineering.
Because look at it, what's the difference? Like you just said it yourself. Like if you go and you say, hey, I want to go ChatGPT and I want to basically create like a marketing campaign for myself, you would provide all the information yourself manually, get the output. But then if you think about, hey, I want to put this to be automated for myself, like I want every day to get this. Well, how does it get the recent topic? What do you need to do? How does it get your brand preferences? How does it get, if they change, right? They might change. So you don't want to go manually to ChatGPT and it may change them. So as soon as you entered automating stuff, then it became a thing of its own. Then it became the context engineering. You try to automate a large language model doing something, and you need to provide it the right information. That's when it became a field of its own.
Exactly. So it's like we're building systems that really manage the memory, they retrieve relevant data, and then they integrate these different tools. For example, like we said, the email or use the APIs to go pull that, and then it really enables the AI or the not necessarily the models, right? Because the model is one part of it; it's the brain, but it enables the tools that you're using to kind of complete and handle more complex tasks rather than just one shot things, and that's where that's where kind of agents come into play. Okay.
Yeah, correct. Because think about it, like informations are somewhere. They can be like, an example, we said, hey, you will be copying pasting, you will be copying from Gmail. So you might be using Gmail or Outlook or whatever. That's one system. You can access it using an API. Some information might be on disk, some information might be in a database. So it all depends. So that's why the kind of like you need to create the art of like how do you fetch that? That's the engineering part of it, right? You're connecting the systems. But then where the special and secret sauce is, well, what to get when. Like the easiest, like if you think about it, you're building something new, the first thing that comes to mind, why did I provide everything to the context? Like why did I just give everything to ChatGPT? Because I've seen actually if you go and just paste up like a whole book, for example, in ChatGPT and tell it to give you like a summary of it, it does a good job, right? And that will be your first assumption. Hey, I just want to put everything in. Why is this a field? Why are we calling context engineering if I can just put everything in there? Well, the thing is, we are still at limits. Like large language models are still not that good of handling large contexts. Like you will see marketing, like you will see Gemini 2.5. They actually have 1 million 1 million tokens context window. I'm not even sure to what that relates in the real world. I think it's maybe even a couple of books that you can put inside of the context window. But all the recent papers that like people are doing to evaluate the performance, it's seen that actually performance drops in like in specific tasks. That being like they might not follow instructions, they might hallucinate more. Most of the benchmarks that these kind of like teams did initially when they built like large context windows was, hey, can it find a needle in the haystack? Like they would just put like a random sentence somewhere in the big context and be like, hey, can it find that type of sentence? And it works, but when you test it on like real world examples, you see the performance degrades. Then when you see that limitation, then you start to think, okay, I can't really rely on a really, really big context, at least not right now. So if I'm building systems right now, I need to architect it in a way that it always has the right and right and correct amount of information that it can do the task. So that's why it became a field.
Yeah. So if you think about these models as just they don't have any memory, they're blank slates every single time. But you have to, like, the systems that we build have to provide the right information. So essentially they now have the pieces that they need in order to accomplish these complex tasks. And like it's about taking out and putting in dynamic content based on where we are in the cycle of completing that particular task.
So this is a good thing you mentioned. Like, hey, they don't have right now. They don't know they don't know anything, right? But they know like the world, right? They don't know the rules in the world.
What they've been trained on, yes.
Yeah, they've been trained. Like they understand a little bit on like how do you form sentences. they even learn because of like learning the world. They also need to understand a little bit of physics, so they know like general things. But at the best to think of them, imagine that you're new to the job. So every day they are new to the job. It's their first day. Every day is their first day at the job, and they need to do they need to do the work. So what do you see for humans, right? When they're new to the job, they initially struggle. They take a long time to get up to speed, and essentially when they learn more about the job at hand, the requirements, and they know the context and know the customers, they're able to do really good job. And we see actually in our company the best performance in the company are the ones that know everything. Like they are able to do a lot of context, right? They understand the customer context, they understand the internal context, they understand how our system is built, and they're able to make rapid decisions based on that. Well, imagine this. This is the same problem for LLMs. They come, they're just new to the job, but you want them to operate at that level as you on that first day. So it's hard, right? So how would you approach giving it to an intern, right? You want to give them a lot of resources to start, but the humans can't really take that much information at once. Well, large language models can. So if you think about it, if you give enough good resources to an intern that they can do to do that to a task on their first day, well, that's the problem that we're solving here. Like give the large language model all the resources it needs to solve that problem today, because even on the next call that you're calling large language, it already forgot everything, so you need to start over again. So it's again a new day on the job.
Exactly. So okay, so let's kind of move on to like some examples, and we get a lot of questions a lot of times, and it's we're building agents, and agents rely on what we call RAG, retrieval augmented generation, right? So essentially, can we kind of go through that process of how an answer gets done, or how how this agents actually work? Maybe like a 60-second overview, so folks can understand that. We've talked about this in like prior episodes, but it's a good reminder that understanding of how this works, and then we can start answering some of the questions that people have around there. Well, how does it know the right answer from my data, and what techniques do we use to actually do make sure that it has the right context in order to answer, and so on and so forth.
Right. We can go with a simple chatbot first, right? And all people know, like language models do hallucinate, right? They are able to make up information sometimes, but also we know that they know a lot about the world, so they also are correct a lot of information. If you now look to GPT and ask it about something in the world, that being a specific maybe school and like their information, they might even know and provide proper one, but it might be outdated
because it was trained on that data, and but there is a frozen period in time that it was trained on.
Right. So
Yeah.
the way to solve it is to give it fresh data, because what was proven with like as the large language models increased in size is that they can reason, and then you can put a certain certain text in there and tell, hey, answer this type of question based on that type of text. So basically, RAG is just information selection. Basically, you're selecting information from somewhere, right? So it's just a overloaded world. RAG is actually a problem that's been trying to be solved in the industry for the last 20, 30 years. There's a lot of companies trying to solve this because it's an enterprise type of use case as well. Like that being, hey, find me policies, answer me questions, how we operate as a company, find me this, find me that, right? So it's actually just selecting and finding information. Why? Well, because if you find the right information and give it to a large language model, it's able to answer that type of question. So how generally, if you're building a chatbot, if somebody asks a question, you probably take that question, try to enrich it with context, like try to give it a context of your institution, then search your information, get the relevant information, provide it to a large language model, and say, hey, this was the question. Can you answer it based on this content that we found? And the best kind of like chatbots will be the ones that have the best RAG implemented with all the different heuristics, techniques. It gets really advanced there. But that's the simplest way to explain it. It's just information selection.
Yeah, but there's a lot that goes into it, right? Like if you think about, for example, we just deployed, there's a couple of partners that have deployed, that built our discovery, our generative search tool discovery on their website, and in a couple of schools' websites. And one of the questions that we get back is, it's like, well, the answers are not correct, or the answers are not, it can't find this answer. And it always comes down to, well, like, what type of information are you putting in a knowledge base? And in a lot of cases, is because that knowledge base or that agent needs to understand, sometimes it's conflicting information that's in there. There's a hierarchy of information as well. So if you upload a whole catalog, we don't just give the whole catalog to answer the question. What we do is this technique that's called, obviously, retrieval augmented generation, but there's a lot of different steps that go into it. We first decode all of the information, all of the text, including things like pictures and things like that, and you put all of those into what's called a vector database, or you essentially decode that, and you put all those chunks and all that information, and you add metadata to it into not just a vector database, which is more of a kind of a heuristic type of database that understands meanings of words and meanings of text and so on and so forth. But also you attach additional metadata around it. You attach, it's like what type it is, what keywords, what sections of the website it's coming from, what URLs, the dates, how relevant this is. So all of that is put all that information into a database, right? And then what the agent does, it's when that question is asked, the agent breaks that down into kind of the intent of the question, and it reorganizes that question or whatever you put in that string into kind of meaningful, more direct type of query that can be maybe it can separate it into you're asking a complex question or a multi-part question, so you need to divide that into two different intents, or you have it one intent or three. So you need to understand that. So the first step is breaking that down, and then going in and for each one of those parts, looking up and finding relevant information. But because you can find information, or tell me about financial aid, or tell me about, like, you can find like hundreds or thousands of different pages and chunks around it. That's not what you're going to return, right? So what happens after?
Yeah, so there's more steps. Like it's not just a single step of searching. Like you'll have multiple steps of searching, right? You'll get a big chunk of data. They might use a different type of model that will help you to kind of like reduce that to something that's more meaningful. Because right now, again, like everything in
Well, so for us, let's go deeper. Like what, like, maybe a little bit of like what do you do?
By the way, guys, a great introduction so far to how this works. If you're looking for a position in element engineering team, we.
Hey, I think I know a thing or two about it, but sure.
But yeah, so what we do, as Ardis explained really well. So there's two steps, right? One is for the data preparation process. So we need to first prepare the data. So even if you have a big PDF, right, you need to first understand it, parse it, understand the images, because PDFs are built for humans. They're not built for large language models. So you need to like parse them, understand them, then define like whole chunks of it based on meaning, right? It needs to be meaningful. Potentially extract keywords and metadata around it, right? Well, what the topic it is, to which section it belongs, what was the title in which it belonged. These are all grammatical meanings, because a sentence put in two different parts of the PDF might not mean the same thing. So you need full understanding. So there's a lot coming into data preparation. When the data is then stored, that allows you to search it. You can search with methods. All of us probably know, for who have been in the industry, there's like keyword search, right? You have a text and you search it by a specific keyword. Still relevant, so it's not so I will mention why. And you've seen like recently with large language models and people talking RAG, everybody will mention semantic search. Well, you actually use a machine learning model, your content that you prepared. Well, in the preparation process, you actually generated also a kind of like a vector of meaning. It's just a vector of numbers, a matrix of numbers, however you want to represent it. And you can then compare them using some machine learning algorithms. So when the query comes in, you can convert that query into a vector and then compare these two vectors to their distance. So that's a semantic search. And you also have the filtering, right? The same thing as you do if you enter any type of software that you use. You might have, hey, find me all people that are active, right? That's basically looking by a property, right? You're not doing keyword search or anything like that. So we basically now we combine all three. We do the filtering to narrow down the results based on the topics and based on the kind of like what's at hand. Is it financial aid? There's these programs. What's the information? We are doing semantical search to be able to match on things that semantically relate. Generally, semantic search models right now in the industry, they're really good for really high scale search. Like if you're searching millions of documents, but they're not entirely accurate. Like you will get a lot of results that match, because semantically a lot of things can match, like money and finance can match, right? But then maybe if I'm asking for money, I might be not asking for financial aid. I might be asking for tuition. So these are separate things. So it's important for the distinction. And also keyword search matters, because why? Semantically, you can't capture everything. Like if you're talking about program codes, right? Hey, I had CS 101. Well, that has no meaning semantically, right? It's just a code that we humans derived, or it's easier to communicate away. So machine learning models don't know and can't really associate a meaning to it. That's why keyword search is important.
So it's a combination. So we use a combination of both keyword
Correct.
and semantic meaning to pull the relevant chunks.
Correct. And then afterwards, you have a post-processing step as well, because you, as we said, you get a lot of results that match. So you need to do something else. There's other machine learning models out there that allow you to do a more expensive search process, but on a reduced subset. So if you're getting like 1,000,
and it's called a re-ranker, right?
Re-ranker mostly, but you can also use a large language model to do the same thing. Depends on like on the economics of. But basically, what's it doing? It's kind of like ordering that initial result set that you got, probably 1,000 records, for example, and it's ordering that in, for example, because you can't really put everything into context as we explained before. And you probably want to get like up 10, depending on how much prepared your data has been beforehand. So if you have like chunks, 2 sentences, you can do more. So all that needs to be fine-tuned and optimized for a use case. Every industry has different kind of like gotchas. So law will have different problem. Health will have different. Higher education has different. So kind of like it's really industry specific, and that type of, and then the type
even coding, right? Even coding, like if we think about like encoding, like that's an example, and we can go into that as well. But like what files do you bring into the context so he understands? You know what I mean? Like you can't shove in your whole code base in there for some of this larger code bases. So you have to find like what are relevant files in order to bring in.
Right. And what's really interesting, if you see, there's a couple of startups right now that are really like booming. One is called Cursor, but there's another one called Windsurf. They're kind of like taking.
No, yeah, we've talked about Cursor in this podcast before.
Right? Shame on me, I haven't watched that.
You gotta listen to this, man. We talk about good stuff.
But what they saw, depending on the startup, some startups are totally doing semantic search and like doing advanced AI techniques. Some have seen success with just doing regular keyword search, using like terminal search, like you could like searching files on your computer. So they're mixing and matching this. So, and also like using your behavioral patterns to like detect what you might look up for next. Interesting. Like, you need to really apply it to the domain specific. So being a domain expert is really important as well in these types of problems. That's why domain experts generally are like a lot of people are afraid with like AI and taking their jobs. Well, it will just kind of make it much more powerful. Like you can apply your expertise to solve kind of higher level type of problems. That's kind of like what I'm seeing right now. Every domain expert just being applied to the like solving these. Like, hey, how can we automate more to bring more value to the economy?
Right. Yeah. So if we go back to kind of the, if we follow the thread, or if you go back to kind of how the thing works. So we're at the stage where we have all this data. We're doing some kind of search on top of it. It's not just a search because there's so much information that can be returned. We pick the top 1,000 results from it based on this advanced techniques, and then you do post-processing on that. And the way you do post-processing is you use another AI to do what we call re-ranking, and that essentially now takes all of these chunks and says, make sure that you give me the most, order this in the most relevant way based on the question or the input that I provided you before. And now what you get is an ordered, type of data. So and then you go further than that, and you can have other techniques that you can say, okay, I'm going to just put all those chunks into the into the model in order to kind of say, okay, now give me an answer here based on the data that I'm providing you below. Don't make anything up. So that's how we get, or that's how the industry gets very accurate responses without a lot of hallucinations, right? And the data that you're pulling in there, it doesn't have to be just data that's text-based on our database, but it's also can be things like we talked about personalization data. It can be a record for a user. It can be a conversation that happened before. It can be a lot of different things. So this technique of retrieval augmentation is very relevant for everything. Like we said, you can pull out files and so on and so forth, and then putting that in there and then kind of stuffing the context. But the part that's really interesting now, we said the question can be like multi-parts. So like you have different threads that are going in and pulling information for those different pieces, and now you have to put all those pieces together, which is in turn like a pretty complex task, because now you have to also reference where you got this stuff, and in order for the answer to be trusted, but also for the model to understand, like if it needs more processing afterwards in the case of an agent that's doing deep research in order to kind of continue that thread, where does it go and how does it do that? So can you explain, like how have we done the citations, or how do we do that in order to give users some credibility?
Right. So that's the second part. And then this is actually more focused towards making your users trust the AI, because there's a new technology, and like with flaws, you want that human transparency. Like, hey, the results need to be kind of coming from somewhere. If you think about it, similar when you're doing your PhD or any paper, right? You want to cite from where you got your results. You haven't hallucinated or made them up, right? So it's a kind of like, it's a technique we solved in academia, right? So it's a technique that then we also use for the large language models to kind of like ensure that the user on the other side can see that the results are to be trusted. Citations are, if you think about it, they're not that hard because when you get your data, you get it from different sources. They're being files, they're being websites, pages. You need to just remember the source. And afterwards, when you're doing that kind of like searching and filtering, you're not just taking the text, right? You're taking all the metadata that comes with that from the pre-processing step, right? You prepared all the data, you extracted all the top keywords, whatever you can about that content, and then you actually return all that. The idea is that the pipeline needs to like return all the data back, and then you can extract things. And then if you actually provide it to the LLM, you tell it, hey, this content came from this page, this content came from this file, this content came from here. Then the LLM can reason about it and be like, okay, because sometimes knowing where something came from also is an information, right? For example, if you have two URLs, right? One is for one lists scholarship tuition for a specific program, for example, while another one for other program. The student asks, hey, what is a scholarship? Or sorry, it can be general scholarship tuition. And the student asks, what is a scholarship tuition? That's probably a general question. You probably want the LM to know that, hey, there's a general page and there's a specific page. So that allows the LM to make the proper decision. And if you think about it, the same as a human. As a human, if you go in and you just implicitly make a decision in your head, if you're reading a page that's specific for a specific program, like, okay, that's probably for that program. If I see it on like the general page, so you make assumptions. So that's how we do. We just pass in back the sources so the LM can make a decision based on that. And it's important that there's multiple factors from citations to kind of giving that another informational signal. But Ardis, I think we kind of went a little bit too far into just RAG. We kind of I think we covered those.
Yeah, no, of course. So let's kind of go back. So basically, we know that context matters. It matters a lot. We are talking about agents specifically, as this workflow has become really important into agents. We talked about, we didn't talk about, the idea of system prompts versus kind of instructions and follow-up prompts. So I don't know if we want to talk about that, but also we talked a little bit about like user input and personalization. So how do you handle the user input? You process that now to get the right context and kind of shape the context for the agent. So where do you want to go next, right? So we could talk about tool calling, like how the new architecture works.
I would touch base on kind of like everything a little bit. Maybe frame it in recent. It's a shameless plug. We released a new feature called bulk jobs, where our AI can practically take work and do it. I think it's a really good use case and a kind of like a case study, actually.
State and memory. I think that's a really good kind of context. Yeah.
And this is kind of like a prime example of context engineering at the current state. Like this is kind of like I think the highest we can go at this moment, at least we in Element. I mean, we'll add more as kind of like technique is advanced. But if you think about it, like what we just recently built was you can use an agent, you can give it a job, that being, hey, I want to get the student to sign up for an open house, or I want to get them to pay their tuition, I want to get them to register for an application, make them do it, right? Like do whatever you can using the system, like you would give to your employee. Hey, do whatever you can to get them to achieve that goal, and let's decompose the problem, right? So if you think about it, so okay, you don't boot up the agent, and the agent now needs to get a student to sign up for an open house event. What we know works best when you need to like communicate to somebody. Well, we know you need to understand who they are, right? So for example, if you have a CRM or kind of like somewhere where you have your data about that person, that record, that can be like, hey, that's who they are. What else do you have? For example, in a CRM, you have all their past interactions. That's really valuable, right? You have all the conversations. Well, what do you have in conversations? You have all the potential concerns they might have, all the potential interests they might have. Though that all ties together. Like you need to understand that before reaching out to the person. What else might be interesting before reaching out? Are they actually interested at all coming here? Like if not, we can stop. Right. So capturing that. Do you actually have a way to contact them as well? Right. We have the email. Did it bounce before? So just you see, just a couple of sentences. That's already a lot of data, right?
So we're trying to mirror like how would a human actually do this job, and like what is the context that the person needs, and it's all the tools, all of the information that they need in order to kind of make this outreach to that person. So the research part, right? So this is the research part.
Yes, and that's my kind of like my biggest advice for anybody else trying to build systems when you utilize context engineering. Always think like a human would. Like AI and large language models, they've always had this problem. Like they're interns starting from zero. Well, think about yourself doing the task. Think about, do you have everything you need to do the task, and how would you do it? And then try to encode it for the large language model.
Yeah. Well, where humans fail, to be honest, is, and this is something that where humans fail is they just don't know what they need, and they figure things out. It's like, oh, I need this, and I need this, and I need this. But if you're an entry level person, you don't have the best practices of sending an email out. Like you might think, okay, I'm going to write this email, but the messaging is going to be just a very generic one, a copy and paste. We know personalization works. So it's like if you put in certain things on your title, you need to know like if the person is in state or out of state in order to put something personal to them. Like we think about it from a student perspective, but also like we remember that sales and outbound sales and cold, sales this is a technique, and it's a problem that's been around for a long time. And the research on the prospect is probably the number one de facto success if that email or that communication is going to go through. You need to understand about this person and their problems or whatever in order for you to produce something that is relevant to them. But not everybody knows that. Humans are terrible at it. Like we don't have all the context.
Right. Depends. Like some people know, some people don't. Right. Depends. Like
Yeah.
let's say,
of course.
Let's say even if you do, right? Even if you do,
an entry level person doesn't really know. They don't have the techniques. They don't have all of that. Yeah.
But if you're experienced, and you're really good at your job, what's the only thing that's holding you back? Scale, right?
It's right. I can write a really good email, but it takes me like 2 hours to do the research and to do all of that stuff. Yeah.
So that's where AI helps us. It helps us enhance us so that all the skills that we have, we can translate into something that's automatable, so that we can focus on other stuff. While this can handle that.
Yeah. So let's be practical in terms of what we build. So you're saying is that the agent there's a research step that's happening right now, and there's context that is being brought in, and that context is all about like what is the data that the agent has access to from things like prior interactions, like you talked about, to
kind of like as Element is a smart platform, we already capture a lot. Mm-hmm. We capture the behavior, the interaction patterns. We capture like what are the topics they've been talking about. So you have all that available.
So this is really important. This is super important, because what you're saying is the result of that interaction or that outreach or the success of it really matters on the context that you have and the amount of data that you have about this person and everything else. And the only way that agents can do that is if they sit on top of a very data-rich, interaction-rich system. So they have to be on top of it. It doesn't matter how smart the agent is. If it doesn't have the right context and the right data, it will not make the right decisions, just like a human.
It will be generic. It will be like all the other.
It will be generic, correct.
Spam emails that you get, like in the giant,
exactly.
All the same. Even missing your name, right?
I remember back in the day, like when we were doing at the agency, when we were doing like personalization, and there was different factors. It's like, hey, we're going to personalize based on if you're in state or out of state. We're going to personalize if your family live in certain zip codes and your household income is this. Based on your program of interest, we're going to personalize. But what you're saying is, like we were able to group people into like 6 or 7 or maybe 10, because we could only write for 10 groups. Like we couldn't write an email for every single person. But now we can do that for everybody because we can stuff all the whole context, and the different data points can be different for everybody.
Right. And think about this. It's more nuanced, because when you're in the old world, right, you are kind of like forcing a decision. Like if a person falls into a cohort, they will receive that type of email, even though they might not really be interested to be talked that way. Like through my interactions with you, like that's non-structured interactions, that being email, SMS, where you don't have a field on the record, right? I might have made it clear that I really don't care. Am I out or in state? Doesn't matter for me. I'll do whatever I can to come.
Right. So let's say we have the right data for them, right? But what you're saying is that we also need to understand the prior conversations and the prior signals as well. So it's not just about the biographical information or all of that. You need to understand what have they communicated with you, summaries of prior conversations, have they, different activities and signals that they have, all of those pieces, like what day is it today? Like, is there events that are happening in campus? Like that data is also the research that you can kind of bring in, because if you're inviting them for an event, you need to understand that. So you need all of these pieces in there. So let's continue, like in terms of how we build our agents. So there's a research phase that happens on.
And as you've already heard, it's a lot of data. And what we have established, that you can't really put everything into context. Just that doesn't ensure that the performance will be optimal. So, but also not everything is relevant. Like even if you get everything is relevant. So you need to compress that, or we call it actually prune that. You need to kind of adapt the content that you have, remove things that are not. That's an important step. So you need to
context pruning. Okay.
Pruning. You need to prune your context before giving it to the AI. Why as well? Well, if you get all the content, and if you're getting it generically, formatting and everything else is kind of like generic. So how do you expect top of the line results with something that's generic? Usually never. Like you always need like really specific. If you focus on something and spend a lot of time and you really give a lot of attention, you get great results. So the same thing, pruning is just that extra step. Go ahead and like, hey, take all this information that we have, use a large language model first to process that, and be like, hey, give me the relevant stuff out of all this that you know about this user that will be really good for this next step and what I need to do to achieve this goal. So then that's how you get like a refined information about the student that's really specific to the goal at hand. And that can also be really minimal, right? Or it can be big depending on the problem at hand. And that's how you would how you would generalize in this way when you're actually building something of a segment of one. You want to personalize on a specific user, and you want to generalize, because how will you build a system? You need to generalize somewhere, but you also need to be really personalized. So context pruning is an essential technique to get that and to make it scale. So that's that's one thing we employ.
So our agents are going through this process of doing their research, looking at what the task is, and then there's this research step, and this is super important because it goes in and retrieves all the relevant information, all of the context about this particular student or user, depending on the task, and then it reasons about what it needs, and then it kind of goes to the next step, right?
And think about it. So you're putting things into context. So what else you need to put into the context? The things the agent can do.
The system instructions, right? Or the tools and the instructions, yeah.
Well, so for people that might not know, well, tools are in part of the context. Actually, we all are, when we are calling all these providers, we actually are charged the same way as passing text or tools, doesn't matter. That's all. For the large language model, it's just tokens, it's just text. So all the tools that it has, that it knows, is context. And what's also been proven, as like increasing of the context that it decreases the performance, same with increasing the number of tools. Already at 20 tools, for example, the AI starts to degrade. At 100, fails miserably. So you need to have a process of also selecting the tools for the job at hand. So that's everything. Again, selecting. And then we talked about retrieval augmented generation, right? And how did I explain it? It's selecting. It's always select the right information, select the right information, select the right information for the job at hand at the moment in time where this is necessary for that next task. So the tools are then also selected, right? So we select information, we select the tools, but both of them are personalized based on what we're trying to do and on the person that.
So if I give you an example, and if we have an agent, so we have the goal is to invite this student to a open house. So first, you're personalizing the message. You're doing some research around the student. So you have the data about the student, where they are, location, all of these different things, prior conversations. But then you're going in and saying, okay, I need some more context about this event. So essentially, you give the agent, say, hey, you have a tool to find out information about events. You have a tool to find out information about what open slots are there for these events. You have a tool to find out about. So then the agent reasons and says, oh, I need to invite him to an event, but I have a tool to find out information about this. So I'm going to use that tool. So what you're saying is the tools are part of the context, and it's kind of this loop that goes on and on in order to bring the right context again. So it's a chain. It's like a chain that goes all the way down.
For example, the student is domestic. We don't need if domestic to US, for example. In US, we know WhatsApp it's not really used a lot. It's mostly for international students. Well, if you have a domestic student in US, you'll probably want to send them a text message using SMS instead of sending them via WhatsApp. Why would you need a WhatsApp tool? You don't even want to have it in there as an option to confuse it. So it's the same as again, if you talk about an intern, right? You don't want to confuse the intern, right? If you also give it a lot of information, you might confuse the intern. So just give it everything it knows, and as you're building their knowledge. Same with your students. You're building their knowledge. You know all the things they will learn, but some things you're holding back. You don't want to tell them at this moment because it will confuse them, because they know they will get it in the future. So this is that example, right?
Yeah. All right. So let's continue on. So let's say that it does the task, but as we're building more and more complex agents, we need to have state like of this agents, like, because they're not just, they does the task. Yes, it goes through the loop and it sends the message, but its goal is not necessarily to just send that message. It's to actually get them to come to the event. So it needs to now monitor and then do additional tasks later on. So there's this idea of, how do you keep the state of this agent, and how do you feed that context back when you revive it again at some point, right?
So the industry calls this basic context writing. Like you will write something somewhere. That it means writing. It sounds like where how do you write it?
Context saving or state. Yeah.
Well, you can put it anywhere, right? You can put it in a database. You can put it on a disk. Or if you think as a human, like when we're doing some work, right, and you have something in your head and you want to offload it, you probably write it on a scratch pad, right? You're offloading it somewhere, able to retain it back afterwards. Like you wrote something as a reminder, and you forgot the task, and you come back to read what you inside. And so this is it. It's basically the context, right? You will write it somewhere. We will actually remember what we in this case of like, hey, agent trying to get somebody to come to an open house. We remember what we did and how we did it. It's really important, the reason. Well, we decided on this based on all these factors. And then
right. If you remember so the context, it's like, why the hell am I doing this thing? It's like it doesn't make sense.
Imagine like a day passes, nothing happened. Like the agent takes a look and be like, okay, let's say 1 day passed, we need to react. What I did 1 day ago, I sent SMS message to get them to here. They haven't even opened it up, like based on something, if we are monitoring that, or they haven't even replied or anything like that. Well, now I need to take a look, whole like what's going on. This is what I tried. I need to also take a look. Maybe there's some other agent that's doing that. So not humans as well, but also other AI agents.
Oh, interesting. So we have a multi-agent system. So agents are operating on the same person. You need to kind of talk to them. That's the context of that.
Right. What did we explain? We just gave one agent one job to get this student to open house, but you might be giving some other agent a job to get the student to apply. But as one step of to apply is also to check, to maybe send them first to an open house. So that other agent might be, so you can coordinate them. So this agent might want to look, hey, what other agents are doing, because I don't want to do the same thing. Imagine the student gets, from me and you, this is the message to do the same thing. It might be a little bit confusing. Why are you posting it? Or I already did it, right?
This is the problem that humans run into. Like, so, and we're terrible at this, right? So it's like and that's why we have CRMs, and that's why we have systems that we try to mimic this, but like we send an email, or like this office sends an email, and then another office sends an email, another office sends an email, and it's like very confusing. They don't coordinate, and it's just all over the place. Yeah.
Would you, as a human, like every decision you want to make, to need to ask like a group of people, can you do it? Right?
Yeah.
It's just you never feel productive. You just want to, sometimes be in the groove and just do your also. So AI would actually, like in this case, right, need to look at what everybody else is doing to see that its actions might be redundant if somebody else is already trying it. It also, maybe the student already did it, right? Hey, that's also context. There might be, hey, they already came to open house. So it takes all that into consideration before deciding again on action to push through. but also it analyzes the conversations, right? It might see, hey, in another conversation, the student might said, hey, I'm really not interested coming to this university. Then why are we inviting you to the open house? We can stop, right? So that's how the system works.
Yeah. So where do you see people going wrong with this agents and context engineering? So it sounds like not it sounds like, but we are actually building these very complex multi-agent systems that need to have very dynamic context and understand what's happening with with the task, so we need to know all of these things. But where do you see people going wrong with this context, like with agents overall right now?
I think the number one cause of like bad implementations or just bad performance is people being lazy about the context, just not wanting to think about it. Because people assume large language models are really smart because they really are, but as we said, they have a lot of these like gaps that you need to like account for, and just people not thinking of and reasoning about it. Like they're just taking it for granted. Hey, I can just put everything in there and I can forget. You can't. Like you need to really be thoughtful and kind of go in and make this be a really important process. If you know, like when you go and implement like a new system, right? You go in and you architect and you make decisions and you plan and you use multiple people's brains kind of to work together to figure that one out. Well, same should apply here, because if you think about it, using context is as easy as just copy pasting something somewhere, right? So when you know it's that easy, you might make a simpler thing out of it in your head. Be like, hey, it's so simple. Why would I make a big deal out of it? I can just put in there and let's see. It already, and for example, on my test set, I'll do like 10 test examples. It works. But you don't know all the variety that exists there, right? So and then you get surprised, which is okay. Like you get surprised and you can get from that feedback, you can refine if you're open to getting the feedback. But basically what I've seen always is just people being lazy and not spending time to think of what proper context should go in there. And sometimes it's just lack of expertise, like not having the domain expertise, like you as a human not knowing like, hey, what should actually go in there. And that's fair. Like not everybody knows, so that's fair. But then the best case, if you want to proceed with your product, then okay, go with something that you think and then learn from the feedback. That's the way how you should approach it. But basically, that's the main problem. Either not knowing or not thinking enough about it.
Yeah. So that's the part that it becomes really, really interesting to understand and to build products that are so vertical specific agents are super useful because we've already baked in the workflow of you know what I mean? Like you're not coming into and essentially building the workflow and like the best practices. That's baked in. It's like, what information do you need? When? How to write stuff? Do you need to send this type of message versus this type of message? All of that stuff is baked in on these vertical agents, and that's what we're building at Element 451. But also other companies are doing that. So like you mentioned Cursor, they're vertical agents for coding. There's Harvey, that is vertical agents for law, for example. There's Sierra, like this company called Sierra, and that's a vertical agents for customer success, and they're building custom agents for that. So you see that the vertical specific agents are winning because they know the context, they know, and they're all usually built on top of these very rich data sources. Like Element is built on top of our CRM for higher education and kind of engagement platform, and Harvey is built on top of all this data. So anyway, so all of that is really important. But I want to kind of take maybe another 5 minutes if you have more, another 5 minutes. So this week, Mark Zuckerberg, he put a message out there on what he calls personal superintelligence. So we've been talking about how Meta has kind of brought together a lot of really smart engineers. They had their earnings call yesterday, and the Meta stock shot up like 12%. And I was like, damn it, I should have just been there. I have a little bit of it, but not a lot of Meta stock. But because they're doing really, really great. But what Zuckerberg put together is this idea of a personal superintelligence, right? And essentially, which personal superintelligence means always on memory rich agents. So it's like you give everybody a personal AI that doesn't just respond to prompts, but it remembers all your goals, interactions, history, even your surroundings, which is crazy, right? It's like now you have an agent that's like, like, holy shit, there's just a lot of context in here that's gathering from you to accomplish all those tasks. Your best friend.
Right? Like that best friend knows everything about you, can talk anything with that person, right?
Personal super intelligence. That's
Personal
crazy.
intelligence, it is. And I really like how he framed it, saying that kind of like Meta tries to solve the kind of like a gap, or not a gap, but kind of like the bridge between the technology and the culture, right? That's and that and not a lot of companies right now are focused on that. We are all focused on, all trying to figure out how businesses run efficiently, how to help people scale. But this is an interesting problem as well. How do you use like AI to also like adapt it to the culture? And this makes sense. Like if you have an AI, like he's specifically talking about his glasses being the product and like the computing of the future, like glasses.
Yeah, I mean, there's just one way of receiving information about the world, but there's others, right? It's going to transform into text and vision and interactions that you're having with people. But all of that is all context.
It is, and it's not. And if you think about it, he's not the same. He's not the only person that said this. Like there's Andre Karpathy. He's a really famous researcher. He actually works for OpenAI.
Yeah, we had an episode here about his software 3.0 talk. So a couple episodes ago. Yeah.
But he said that his vision of the future is not like the most smartest, capable, huge model. He's like, hey, can we build like a really, really small model, right? That can fit on a device, but has the only feature it has, it can go through efficiently through a really, really big context, like enormous context. Basically, you can put your whole life onto that, and basically he's able to think that model is able to think through that. And it makes sense. Like you see people who are on the front lines understanding these technologies and thinking about this and thinking also how to productionize it. And they think that the only problem needed to be solved is the context, because if you have the right context, you're able to make the right decision. And it's, again, if you make a parallel to people, right? If you want the person to make a right decision, they need the context. They need to understand what's going on.
They need the right information, yeah.
So that's it. It makes so much sense that the super intelligence is just being able to have all this information in your head, and then based on the scenario, act, right? Give advice, nudge. Like, you don't think of AI just being kind of reactive. The same thing as what we did in Element, right? We turned the tables. Like most of the AI was reactive, and me and ours were talking like, hey, can it be proactive? And that's how we came to our whole jobs. So think about like these devices being on you, like an engine of you. You're going in the world. They record what you're doing. They can nudge you. They can nudge you. They can also like do, okay, there's things that we already have, like monitor your insulin level, that type of stuff, blood and sugar, hey, you need to take insulin.
Yeah. Yeah. So it's collecting all that data. Yeah.
For example, you're not a socially open person, right? And after like a lot of social interactions, you get nervous. And like it sees like, hey, you already talked to 3 people, generally you'd feel bad after that, go take a break, rest a little bit. That's these social cues, right? And like your AI best friend would be able to do that. Right. So
yeah. It's your Jarvis, right? Your Jarvis. So yeah. I mean, we can have a whole other episode. I think we're running a little bit long on this one, but there's things like context techniques that are at the core of a lot of these. So if you're smart glasses and kind of this vision of the future is like the AI like understands and sees what you see, hear what you hear, and then kind of collect all that context. And then you think about the AI's job is to gather, store, act on this relevant life context. You can think about, well, the challenges here for context and context engineering is like what continuous environment monitoring, we call like ambient agents, like what happens, glasses, wearables. Like these are really, really a real-time collection of information. The recall and summary, it's like, well, you can't store all these things. It's very unusable. So you need to summarize and compress this information. So AI summarizes that conversations, meetings, activities, and surfaces kind of matters later on. But then you also have long-term memory, like problems that you need to solve. Like it's not just this one session that we have right now, like we're going back and forth. It's like these agents need to build what called like lifelong, maybe files on user preferences, behaviors, goals, like you said. It's like, so those things are kind of hierarchical. And can serve as like memory extensions, or so it's really, really interesting. It's very fascinating, like where we're going and the problems that we need to solve to build these agents that are helping us in a lot of different ways. Right now, the agents are dumb. Like we have very dumb agents. Yes, we're moving towards smartness, but it's going to take a little bit longer to get to that. And there's a lot of smart people that are working on this, including you, right? So that's
thank you.
So this is an area where we're going to come back and talk more about like different products and what's happening in industry. But I think, Petar, thanks for jumping on. I know that we're at the top of the hour here, and we can keep going for another hour or two. I just don't want to make this into a Lex Friedman type of podcast where he goes deep into 3-4 hours. So we can keep talking about this.
Talk about my personal life. That's interesting to people, but
yeah, exactly. Well, we can talk for hours with just the RAG and the techniques and kind of all the problems that we're finding there. But I appreciate you kind of jumping on, and thanks again.
It's a pleasure. I'll be glad to come back again.
All right, everybody. Well, hopefully this was interesting and useful, and it gives you a little peek into kind of the frontier issues that we're facing in building agents, which kind of all revolves around this idea of context. Yes, models are getting better, but you can't have really good output on these agents without having the right context, and that's perhaps the frontier that's the most interesting right now and the most challenging. And hopefully you kind of took a little peek underneath the covers on how these things are done and how they work. Until next time. Generation AI is part of the Enrollify podcast network. If you like this podcast, chances are you're going to like other Enrollify shows too. Our podcast network is growing weekly, and we've got a wide range of marketing, enrollment, and higher ed technology shows that are jam-packed with stories, ideas, and frameworks, all designed to empower you to be a better higher ed professional. Enrollify is made possible by Element 451, the next generation AI student engagement platform that's helping institutions all over the country create meaningful, personalized, and engaging connections with their prospects and students. Learn more at element451.com.